One example of extremely slow motion is tectonic plates. These are plates of the Earth's crust. The outer layer of the Earth is known as the crust. And here's a picture showing all the way down, a cutaway view of the Earth all the way down to the core of the Earth. And you really have the outer core and the inner core. But this layer around the outside, which is a few miles thick, which is really thin compared to the entire Earth. It's about 4,000 miles from the center out to the edge. But this outer layer of the Earth, called the crust, is divided into sections that fit together kind of like pieces of a jigsaw puzzle. And these pieces of the Earth's crust are called plates, tectonic plates. And they move around, they drift slowly, because underneath the crust, this layer of the Earth under here is called the mantle, and it's molten rock. This is basically, when you think of the mantle, think lava. Think the stuff that comes out of a volcano. And if you have, for example, look up here, one plate of the Earth's crust and another plate of the Earth's crust, and there's a crack, and some of the mantle in there comes out. That's a volcano. That's an eruption of a volcano. So if you've seen pictures of lava, have an idea of the consistency of molten rock. That's what's under the crust. And so you think of the plates of the Earth's crust as these sections floating on the lava underneath, floating on the mantle. And there are some currents in there. It's very slow. This is not swirling around like water in the bathtub. This is very slow. They move on the order of inches per year. But these plates, the plates of the Earth's crust, move around. And the study of the movement of these plates is called plate tectonics. There are basically 7 large plates and then a whole lot of other smaller ones. And they typically move a few inches per year, 5 to 10 centimeters per year. Here's a map of the Earth, and it shows the plate boundaries. And you can see over here the North American plate runs down the west coast of the United States, but then also out here to the middle of the Atlantic Ocean. And you see these little arrows. The North American plate is moving in this direction. And the Pacific plate, you see, is gigantic. The Pacific plate around here, and it's moving in a slightly different direction. So there's some relative motion along the boundary. And that's actually why we have the Sierra Nevada mountains. As the plates mash against each other, the mountains get pushed up slowly, and that's what formed the mountain range along the west coast right there. So with that in mind, we should be able to answer this question. The Atlantic Ocean widens at the mid-Atlantic ridge at a rate of about 4 centimeters per year. In other words, the plates there, the Atlantic plate and the European plate, are spreading apart right there. And there's actually a mountain range underwater called the Mid-Atlantic Ridge. Here's a little section of a map showing the Mid-Atlantic Ridge. This is Africa over here, and Europe. You see Spain and England and the Mediterranean Sea here. And over on the left side, this is South America, and you can't see, you just see a little bit of Nova Scotia and stuff up here, but North America is over here, so Florida and Texas and stuff, and California. So this is the Atlantic Ocean here, and this is Iceland up here, and all the way through Iceland and running down is this ridge underwater of mountains. And what's happening here is this plate is spreading this way, and that plate is spreading that way. And new rock is coming up from underneath. Molten lava is coming up, and this mountain range is forming underwater as the lava comes up, and these plates spread apart. So we're asked, how long will it take for the ocean to widen by 100 meters? Well, the ocean is widening at the mid-Atlantic ridge at a rate of about 4 centimeters per year. So that's my distance, that's my speed, excuse me. The speed is 4 centimeters per year. And I'm going to rewrite that. 4 centimeters is 0.04 meters, because there's 100 centimeters in a meter. So the speed is 0.04 meters per year. That's the speed. And we're told, how long will it take for the ocean to widen by 100 meters? Well, I want to know the distance. I want to know the time. How long will it take? So I use my equation involving distance, speed, and time. And the equation is going to work like this. Time is distance over speed. And we've seen this equation before. We just put in these numbers. To widen by 100 meters, moving at a speed of 0.04 meters per year. And now you can see why I converted this from centimeters per year to meters per year. Because I have a distance of 100 meters, I need my speed in meters per year. I need the units to be consistent. This way, mathematically, the meters there will cancel the meters there. And I'm left with years. 100 divided by 0.04 is 2,500 years. So that gives you an idea of how fast these plates are spreading apart. 100 meters, which you could just walk, in 30 seconds or run in 10 or 15 seconds, it's going to take these plates 2,500 years to move that distance.